When multiplying rational expressions, you want to factor everything and then cancel like terms, regardless of which fraction it started in. Let's do some examples. Factor everything. My first numerator is a difference of squares. In my first denominator, I can divide out a 2. In my second numerator, it's also a difference of squares. And in my second denominator, I can divide out a 2. This is multiplying, so I can treat it as one long fraction. And if you need to put in parentheses, every single little factor, it may help. Cancel 1 to 1, one from the top and one from the bottom. I have a 3x minus 5 in the top and bottom. I have an x minus 1 in the top and bottom. These 2's are both in the bottom, so they cannot cancel. I am left with you don't have to FOIL or distribute or multiply out the numerator, or anytime you see binomials like this, x's plus something. But in the denominator, since they're both just numbers, we might as well multiply them together. And now this is my final answer. In the second example, let's factor. The first numerator factors. The first denominator doesn't factor into anything. I can't pull out a GCF, and there's not a difference of squares. The second numerator is a difference of squares, square root it. And the second denominator, I can divide out a 3. Put in your parentheses if it helps clear things up, and since this was multiplying, I can treat it as one long fraction. Cancel, one from the top and one from the bottom. And now my final answer. You don't have to multiply out the numerator. You can leave it separated like that. To divide rational expressions, you want to keep, change, flip, and then treat it like a multiplying problem where you factor everything and then cancel. Keep, change, flip means keep the first fraction as is, change your division sign to multiplying, and flip your second fraction. Keep, change, flip. So when you divide, keep, change, flip, and then treat it like a multiplying problem, which means factor everything and cancel. I'm going to factor this one on a separate sheet of paper. My first numerator, my first denominator, I can divide out a 5. Second new numerator, difference of squares. Second new denominator. Some people try to use -1 and 6, and -1 and 6 do add up to 5, but -1 times 6 is negative 6. And I want it to be positive 6, so that's why 3 and 2. Positive 3, positive 2. Now I can cancel. Final answer. Last example, keep, change, flip. Keep the first fraction as is, change division to multiplying, and flip the last fraction. Now treat it like a multiplying problem and factor everything. First numerator. Second denominator, I can divide out a 2 and then do a difference of squares. Second new numerator, divide out a 2. Second new denominator, and cancel. Ooh, I should have put parentheses around these 2's to make it a little bit clearer that they are themselves factors, even though they don't have parentheses, they're multiplied by everything else. And all I'm left with is this x plus 5 in the denominator. This is not my answer. Make sure you realize it was in the denominator, so I need to keep it in the denominator. Final answer.